Continuing from my previous presentation, which went through a floor grill design calculation, I'm just going to spend a little bit of time showing you how we can optimize the floor grill design. So if I just change over to back to the calculation, here's the floor grill, and as we produced our calculation based upon the kind of given dimensions, we showed that the rail was giving rise to a massive deflection and very high stress, so it's 140% over, and the allowable deflection of the whole product is 2.5, so almost all the deflection is coming from the cross rail. For the side frame, well, the side frame doesn't contribute so much for the deflection, and the stresses were quite low. So I think when I look at the problem, I'm thinking, well, we want to up the section of the cross rail, so I guess it's this parameter W that we want to optimize on. And we're gonna run through a scenario now using the Excel solver. So if I get the Excel solver up, what we're going to say is we're going to try to set this target cell to a minimum value. The target cell is this mass parameter here, so I want this to be a minimum value by changing this cell here, which is the W dimension. I'll show you where that is. There, that's this W dimension. That's cell E49 there, and I've also added these constraints using this AND button. But E74 is a stress parameter. So if I go to E74, this is the stress in the cross rail. That has to be less than 265, which is the material yield. I think I can just show you that, the material yield there of 265. So we've got to keep one stress below 265, and the second is the stress in the side rail. So the side rail stress is this value here. That's E87, has to be less than 265. And the total deflection, which is currently 7.1, has to be less than 2.5. So I'm going to press the solve button and let Excel click away until it finds a solution. It's found a solution now. It's got a deflection of 2.5, I see, so I'm going to go with this solution. Okay, and it's got the mass down to 7.7 kilograms, so slightly heavier than I think as the problem was set up, but not much. And both stresses are below 265, so that's below 265, and this is below 265. We have a solution here, and Excel has decided that the W dimension has to be about 76. So there we go, there's a solution to our problem just by increasing this thing here. Looking at the that's a very structurally efficient section. This is not such a structurally efficient section, but if I was going to optimize further, I would look to getting maybe the extreme parts of this section up in thickness, and I would probably minimize the section towards away from the extreme fibers. That would optimize things further. But I hope what this problem serves to show is how useful Excel can be in finding answers to your problems and to optimize your solution. So thank you very much for listening.